Our subject today is the Artist Guitars TweedTone V. You'll notice a strong family resemblance between this and the TweedTone 12A that I did for Artist. To keep costs down, I used as much as I could of this architecture in the new amp. The symptoms for this were smashed preamp tube in the 12X7 V1 position. I replaced that while you're off getting the coffee, and it worked. So you think, oh, well, that's it, pack it up and set it back. No, we have to be a little bit more thorough than that. I also thought I heard a hum in the background, an unusual hum. So that's what we're going to look at. You may remember I said we power things up when we don't know their condition in the current limiter. Going to turn this on. Now it's a solid state rectifier in this, but it still takes a little while for the valves to heat up. Whoa, that's the sound. Something not good is happening here. That sound sounded like a short to me. I've turned off the lights so we can see if there's any arky-sparkies in either the preamp tube or the power tube. You can see the filament coming on. Okay, nothing unusual yet. Okay, there's that weird sound, cracking sound. Well, maybe I was wrong. That's always the first time. Can't hear any odd noises now. Using a cloth, I'm going to just give that V1 a bit of a jiggle. All good. Power tube. Uh-oh. Here's that sound. I'm hearing that sound again. What happened after I jiggle this power tube? Maybe not. Anyway, I'm going to pull the amp out and we're just going to give it a bit of a check over. I don't believe in just swapping out a preamp tube and sending it back to the customer. We certainly don't want it to come back with a report of same fault. Sometimes it's a bit of a challenge to figure out how amps come apart. This one, fortunately, is pretty easy. Now, there's no separate plug-in speaker, so we have to disconnect it from the speaker terminals. Oh, that was nice and easy. That one I can't reach, it's behind that 6V6. So what we're going to do is we're going to bring out the chassis a bit. Now I'm going to pull this out so I can finish removing the chassis, which is currently held in place by that speaker lead. Now you just got to be really careful when you're doing this because I haven't discharged anything. So as you can see, it's got some fairly sizable capacitors. Nichicon brand, nice. That can give you a pretty nasty bite. So just be very careful on where your hands go when you're pulling one of these apart or pulling any amp apart. I will discharge it, but there we go. To change the 6V6 or to remove the chassis, this is going to have to come out. There's not much space between the tube and the speaker. Not a big problem. It's like literally a matter of minutes to change a tube. Yes, you wouldn't want to be doing it at a gig, but hey, who's going to be using a 5-watt amp at a gig? Do you ever find you have large objects in the middle of your workspace? Harley? Yeah, I'm talking about you, mate. So we've got no schematic, so let's have a look and see what we can recognize in this layout. So usual protocol standards are red is our HT, which makes sense because we see here the 4 rectifier diodes, and green is more often than not the filament wiring. We've got a 4 amp fuse here, so that would be definitely the filament wiring. So there are our 2 fuses. So here's our 4 rectifier diodes. Now you notice something a little bit unusual, and that is that each one of the rectifier diodes has got a little capacitor running across it. So why is it so? When a diode is rectifying, the voltage is going first one way, then it's flipping over and going the other way. And it's at that flipping over stage that the diode can generate noise, and which can be impacted in other parts of this circuit or in other equipment. So one way of squelching that noise is by using a capacitor across each rectifier diode. This is obviously the main filter cap, pretty big actually, 220 microfarad at 450 volts. We can take the liberty of having a large filter capacitor because we don't have a tube rectifier, which should be limited to, well, depending on what the tube rectifier is, but certainly you'd be looking at, say, 60, 70 microfarads at the top end. Oh, this is another good thing. Here's our preamp tube. As you can see, 9 pins. Here's our power tube, 8 pins. We like this. We like to have the filter capacitor as close as possible to where it's doing its main job, and its main job is to provide smooth ripple reduction to our preamp tube. If you can see there, the protective paint has been rubbed off, and you probably can't see, but this type of jack has got in fact it's this part here, has got a ground connection to it. Another good feature, we like the circuit to be grounded near the input jack, and we like a filter cap close to where it's doing its job. Okay, so when we see two 100 ohm resistors, more often than not side by side, they're the hum balance resistors. Now this has just attracted my attention. It's a fairly high wattage, not too high, maybe, what's that, 1 watt? Probably not even 2 watts, I wouldn't think. But I'm thinking that that is going to be our cathode resistor, because I'm seeing here 22 microfarad, 50 volts. So that's the cathode bypass. For this would be the cathode resistor, and we can double check that by going to pin 8, and not that one. So that end is going directly to pin 8, the cathode. So that is the cathode resistor, and that's definitely copped a whack of heat. I don't know if you can see the discoloration clearly, but that should be around 470 for a 6v6. Let's put it on ohms. It is, it's 466, which is well within spec, but it's clearly discoloured. And that's ringing a little alarm bell. Now, here from our main filter cap, we then have, oh, I think I've been here before. This looks like my work, or someone else. That's a dropping resistor, as you can see, fairly hefty, and I like the way I or someone else has elevated that resistor off the board. This would be the next node of filtration here, but that would be the dropping resistor for the next node. This looks like a familiar 1.5K. So I'm going to guess and say that is a cathode resistor, and that's going to be its cathode bypass. So this will be going either to pin 8, on that side, nope, or pin 3, nope. Okay, so that is the cathode resistor for that first triode, and then we'll probably see 100K, 100K, they're probably the plate resistors. This is going to be some sort of tone shaping. This is, where's our presence pot? I or somebody had replaced that and once again elevated it off the board, thinking that that and that cop a fair bit of heat. 470, that's a classic screen grid resistor value. Screen is going to be on pin 4, so let's just double check that hypothesis. Yes, so that's our screen grid resistor. So R17 is our grid leak resistor going into the control grid of pin 5. All right, I think that's the main thing. That's concerning me. And I don't know that we need to size this to be the same as a cathode bypass cap for a normal gain stage. This is just serving a different function. I think well, we're going to stick with that because that's what the factory designed. But I can't remember what I put in my Tweed Tone 12. Probably something like 200 microfarad or something like that. I would have gone up a fair whack. All right, this is one of my little adapters that I made. So it's going to be, this is going to replace the speaker. So this is going to go into the speaker terminals. And this goes off to my workshop speaker. Here we go. This plate voltage should be up already, I would think. 372, 369. So we've got 22 volts on the cathode. Let's just check our preamp tube. Plate on pin 1, it's 238. We always check the cathode, that's going to tell us a bit more. We expect somewhere between 0.9 and 1.9, I suppose. 1.6, that's pretty good. Sometimes when it's not an identifiable fault, you just have to go on your gut feeling. And I'm not happy with this thing gathering so much heat. We'll take a measure of it now and just see exactly how much that's dissipating. I think that's a 1 watt resistor. And then we've got these solder joints just don't look the best to me. You probably can't see it, but this one here, pin 3, which of course is your plate, that doesn't look like a real secure solder joint. I might be imagining it, but it looks like there's a crack there. And they're not shiny. See how this one's shiny? That one's not shiny, that one's not shiny. So I think I might resolder the base pins of the 6v6. So I'll lift off as much solder as I can and then resolder it with fresh solder. I will probably end up replacing this, but I'm just curious to see what sort of power we have that across that. I want to measure this resistance. I think it was 466 from memory when we looked at it before. Yep, 466 ohms. That's for the cathode resistor. Now, apply power, make sure I haven't got anything in there which is going to go zappity-doo-dah. We've got a speaker plugged in. All right. It's still coming up as the tube starts to conduct. The power supply would be pretty much instant. That power tube, which I'm tapping now, is fairly microphonic. Now I've got to be very mindful of this amp. It's a low cost amp, so I can't present the owner with a $200 bill because he could buy another one. So whatever I do has to be, so normally if this is a higher cost amp, I'd replace that. I've already replaced the preamp tube. Okay, that might have had time to settle. And the voltage across that cathode resistor is 22.46. Now I want to measure the voltage between the plate and ground. It's going to be 371. But because this is a cathode biased amp, we need to measure between the plate and the cathode, which is pin 8. And that's 348.2. What's that noise? Yeah, man. Yeah, that power tube is making some noise. Cathode's gone up to 25.2. So our current is going to be 25.2 divided by 466. That's 54 milliamps. Whew. That little baby's running hot. And so the power going through it, I know we can say this is the cathode current, which is going to be the plate current plus the screen current. I normally give about 8% as the screen current, so we'll say that the plate current is 92% of that times 0.92, so about 50 milliamps. So to calculate the power being dissipated in that tube, we're going to use the formula power equals VI, and we said the plate, the voltage across from plate to cathode is 348. So we'll do, that was the answer for the current, times 348.2. That's a massive 17 watts. A 6v6 is good for a maximum of 14 watts, which means our tube is running at 17, divide that by 14, 120%. That is way too hot. So here's what we're up to now. I replaced that cathode, 470 ohm cathode resistor, that I've replaced it with a 560 ohm 3 watt and raised it off the PCB. We'll measure that shortly and see if that's succeeded in cooling it down. You might notice the solder connections are all nice and shiny now. I removed all of the solder from there and reapplied fresh solder, because I was pretty sure there was a crack in the solder for pin 3, which would definitely not be a good thing. All right, let's do some measurements. I've got power on. The voltage at the plate is 376 exactly. The voltage at the cathode, or across the cathode resistor I'll measure, is 23.5. Let's check the voltage at the screen. 372.3. Now I'll discharge that capacitor. That pop and crackle is me suddenly dumping the voltage down on the plate, which the transformer would think, oh, there's a signal, I better amplify that. So that's why we hear that. So that new 560 metal film Vichy resistor is 552. So to calculate the current going through the cathode, we'll call that IK. And once again we're going to use V equals IR. So I equals V over R, which is 23.5 divided by 552. So the current going through the cathode is 42 milliamps. What did we have before? 50 milliamps. 54 milliamps. So that's, you know, way cooler. I'm happy with that. Let's calculate the power dissipation through the tube. So we've got V across the tube is going to be V plate minus V at the cathode. VK equals 376 minus 23.5 equals 352.5. We'd expect it to go up a bit because we're drawing less current, less drain on the power supply. Let's just compensate for the screen current. So I'm going to say that once again is 8%. So let's do 42 times 0.92 because we actually want plate current. So we're going to say IP equals 38.6. It's not exact, but hey, it's pretty darn close. Power is 352.5 times 38.6 is 13.6 watts. On a 14 watt tube, I think this is going to be absolutely perfect. Divide that by 14, 97%. That is pretty much perfect cathode biasing. Anywhere from 90 at the very lowest end to 105, maybe even 110. Now turn back the power and just make sure nothing untoward's happening. I've got my speaker plugged in. This is where, if you're not careful, you're going to do some damage, usually to yourself or your equipment. My discharging tool was still connected to the plate of that 6v6. If I turned it on, I would have burned up that resistor had I not put in a fuse in series with it. So, of course, ever since putting the fuse in, I've never forgotten to unclip my discharging tool. I think it's appropriate that I play my Artist Guitars 335. Yay, there we go. That's on volume 9 o'clock. Let's go up to 12 o'clock. I'll try putting a switch over to the boost. Now, the normal and boost is different to what I put in on the TweedTone 12. And if you look at the TweedTone 12 video, I think I explained what I did, which of course I prefer to the boost and normal on the TweedTone 5. Not that there's anything wrong with this, but I just prefer what I did. See that bias, that new bias, so much better. This is a humbucking pickup. I'm on 12. And the thing's beautifully clean. Take it up even higher. Okay, so at 2 o'clock we're getting some overdrive, but I reckon that'll clean up with the volume bring down. Yeah, beautiful. I want a bit more top. We're going to call this a successful repair. So that's how you can repair a small tube amp without a schematic, which we didn't need to refer to. It had a couple of issues which we corrected and some improvements that we've made, so I reckon this can now go back out into the wild. It will sound better and be more reliable than ever. I don't think I should say, but I will. I've been talking to Ian Bush, the CEO of Artist Guitars, and we have together been coming up with some enhancements to both the tone and reliability. And when I say reliability, there's nothing unreliable about this amp. I just think that's the wrong value, that and that. But the improvements coming up are going to make this one mighty little champ beater. But I shouldn't have said that, so ignore I said those words. But check out Artist Guitars in a few months' time. Well, the little Tweed Tone V was a successful repair. Because it's a low-cost amp, you have to be practical about what you're going to do. Some things you would just automatically do on a more expensive amp, but you can't really spend more than an hour on a repair here, or else, you know, we're getting too close to a replacement cost. So I spent a little bit more time on this than I would normally. I could have replaced that cathode resistor by doing a top of PCB repair, but I knew you were watching, so I lifted the PCB out and resoldered it properly and put it back in. That would have taken me over my budgetary time. I think I'm glad that I did that resoldering on the 6v6 base. I think that was an issue, or going to be an issue very soon. So it's done. Did you like that? Did you get something out of how to repair a low-cost amp with no schematic support? We might do a few more. If you like it, if you go, no, Chris, that's a pile of doo-doo, then it'll stop. Because I'm here to make you happy. All right, bye for now. See you at the next video.